Hello everyone, welcome to today's geography class. Our topic is solar radiation, heat balance and temperature from class 11 NCERT. This chapter is very important for understanding Earth's climate system and it's frequently asked in examinations like EMRS PGT, NVS, KVS, DSSSB. We will go through the key concepts in a clear and systematic way. So, the first question is define insolation and explain the primary factors causing its variation on Earth's surface with examples. So, the answer could be like this for 4 marks for upcoming EMRS PGT examinations. So we can write this like this: insolation is the incoming solar radiation received by the Earth, traveling primarily as short wave energy. The variation factors are the angle of inclination. The tighter the angle or near the poles, the larger the area over which the energy is spread and reducing intensity. For example, low latitudes receive vertical rays, hence higher insolation. Next controlling factor is duration of daylight. Longer daylight hours lead to greater total insolation. For example, high latitudes receive more insolation during the summer solstice despite the low angle. Next factor is atmospheric transparency. Cloud cover, dust and gases absorb or reflect solar energy. For example, clear skies result in higher insolation reaching the ground than the cloudy skies. What is the solar constant? Question number 2 is what is the solar constant? Why is the insolation received at the surface less than this value? The answer is the solar constant is the average rate of solar energy received at the top of the Earth's atmosphere on a surface perpendicular to the sun's rays. Its value is 1.94 calorie per semi-square per minute. The reason for lower surface insolation is that the Earth's atmosphere scatters, reflects and absorbs a significant portion of incoming radiation. Approximately 35% is scattered or reflected back to space, that is planetary albedo, and about 14% is absorbed by atmospheric gases and clouds. Thus, only 51% of the solar constant reaches the surface. Question number 3. Explain the concept of Earth's heat budget. How is the thermal equilibrium maintained? The Earth's heat budget is the balance between the total amount of solar energy absorbed, that is insolation, and the total amount of energy radiated back into space, that is terrestrial radiation. So, maintenance of equilibrium is like that. Earth absorbs the remaining 51% of the incoming shortwave energy, and the Earth's surface warms up and radiates energy back to the space as long wave radiation. So, how it maintains the balance? Over a long period, incoming short wave energy equals the outgoing long wave energy. This near perfect balance ensures the Earth's average global temperature remains stable, maintaining thermal equilibrium. Question number 4. Describe the term albedo. Provide an example of a surface with high albedo and explain why. Albedo is the fraction or percentage of incident shortwave solar radiation that is reflected by a surface back into space. It is a measure of the surface reflectivity. For example, fresh snow or ice has the highest albedo up to 70 to 90%. Reason its bright white color means it absorbs very little light or heat and acts like a mirror, reflecting most of the incoming shortwave radiation directly back. This high reflectivity is why snowy areas remain cold as they retain minimal energy. Question number 5. What is a temperature inversion? Briefly explain the most common type. Temperature inversion is an anomalous atmospheric condition where temperature increases with altitude instead of decreasing the usual lapse rate. So, it occurs on long, clear and calm winter nights. The ground radiates heat quickly and cools rapidly. The air layer immediately above the ground cools by conduction, becoming denser. The air layer above remains warmer, creating a stable atmosphere where normal vertical temperature gradient is inverted. For example, valley floors experiencing heavy smog or fog. Question number 6. Differentiate between the thermal equator and the geographical equator. Geographical equator is the fixed imaginary line at 0 degree latitude separating the northern and southern hemisphere. So, the thermal equator is an imaginary line connecting points of the highest mean surface temperature across the globe. So, what is the difference? The geographical equator is static, the thermal equator is dynamic. It shifts north or south seasonally, primarily due to greater proportion of landmass in the northern hemisphere and the apparent movement of the sun. It typically lies slightly north of the geographical equator. Question number 7. Define isotherms. Why do isotherms bend more drastically in the northern hemisphere than in the southern hemisphere? Isotherms are imaginary lines on a map that connect places having the same average temperature at a specific time or period. So, bending reason is land-water contrast. The northern hemisphere has a much larger landmass compared to the water-dominated southern hemisphere. So, what is differential heating? Land heats up and cools down much faster than the water. For example, in winter, isotherms in the northern hemisphere bend southward over continents, that is colder land, and northward over the oceans, that is warmer water, showing a greater thermal range. Question number 8. Distinguish between conduction and convection as modes of heat transfer in the atmosphere. What is conduction? Primarily solids and air layers in contact with the ground. So, the process of conduction is heat transfer occurs through direct contact between molecules without mass movement. Atmospheric role of the conduction is that important only in the lowest layer of the atmosphere where air is in direct contact with the heated surface. So what is convection? So convection medium is fluid, liquid and gaseous like the atmosphere. And the process of convection is heat transfer occurs through the vertical movement of the heated air or the rising warm air and sinking cold air. So atmospheric role of this is the principal way that troposphere is heated by the earth's surface, forming convection currents. For example, thunderstorm formation. Question number 9. What is the role of advection in heat transfer? Give an example of its impact on Indian weather. Advection is the horizontal transfer of heat by the movement of wind or air masses. It is vital for distributing thermal energy across latitudes. So what is the impact on Indian weather? North Indian heat waves, that is hot, dry winds blowing from the west, like from the Rajasthan deserts across the northern plains during summer, are a classic example of heat advection. So, and the next is winter cold waves. The horizontal movement of cold, dense air masses from the Himalayas or the Central Asia into the northern plains causes cold waves, which also a form of cold air advection. Question number 10. Why is the temperature range, that might be diurnal or annual, why is the temperature range over water bodies much lower than over land masses? The temperature range is lower over water because water has a significantly higher specific heat than the land. Water requires much more energy to raise its temperature and holds heat longer. The land heats and cools quickly. So, how does the mixing happens? Water is transparent, allowing heat to penetrate and be distributed over a greater volume through currents and mixing. Next is evaporation. Evaporation from the water surface uses heat energy, which keeps the temperature of the air above the ocean lower. This effect creates maritime or equatable climates near coasts and continental or extreme climates inland. Question number 11. Explain two primary controls of temperature distribution with relevant examples. First is latitude. It determines the intensity of insolation received, as the angle of sun's rays varies with latitudes. For example, Chennai, that is closer to equator, is consistently warmer than Shimla, that is in the higher latitude, even though the Shimla is higher in altitude. Next controlling factor of temperature is altitude. Temperature generally decreases with increasing elevation in the troposphere at an average normal lapse rate, that is 6.5 degrees Celsius per 1000 meters. For example, although Mount Everest is at a lower latitude than the Arctic, it is perpetually covered in snow due to its extreme altitude. Question number 12. Explain the role of terrestrial radiation in heating the atmosphere. Terrestrial radiation is the long wave energy emitted by the Earth's surface after it has been heated by the insolation. So what is the atmospheric heating process? That is solar shortwave energy largely passes through the atmosphere without heating it significantly. The Earth's surface absorbs this energy and emits it as infrared long-wave radiation. Greenhouse gases like carbon dioxide, water vapor in the atmosphere are highly effective at absorbing this long-wave energy, warming the air around them. Therefore, the atmosphere is heated indirectly from below or by the Earth's long-wave radiation, not directly from the sun. What is the greenhouse effect? Name two primary gases responsible for it. The greenhouse effect is the natural process where the Earth's atmosphere traps some of the long-wave terrestrial radiation, preventing it from immediately escaping into space. This natural trapping keeps the planet warm enough to sustain life. So what is the mechanism? Greenhouse gases act like a glass pan in a greenhouse, transparent to incoming shortwave radiation but opaque to outgoing long-wave radiation. Primary greenhouse gases excluding water vapor are carbon dioxide and methane. This brings us to the end of our discussion on solar radiation, heat balance and temperature. We have revised the core concepts and examples that are most relevant for examinations like EMRS, NVS, KVS, DSSSB. Thank you for listening and best wishes for your preparation.